this is the November 2018 paper, but essentially all our papers are in the November itself. Okay, so it's just a Cambridge kind of thing. Okay, the papers. So 2018 paper, then this is the paper number. So paper 1 or paper 2. So in this case it's a 2, so this is referring to paper 2, and then this is the question number. Okay, so if you have the yearly tenure series itself, what you could do is just flip to the year, go to that paper, and look for that question. Okay, and the question will be a good practice for your circles. Okay, then differentiation and the equations of tangents and normals. Okay, so those I extracted out from different papers over the past few years. I hope that it is sufficient practice for your WA1. Okay, the answers itself. Okay, I will be putting it up onto Google Classroom. In case you forgot about our Google Classroom's existence, you still have that. I'll put up a soft copy onto it. Okay, any questions? No? Alright. Then, so this one, no deadline, but please just go and do, okay, practice. Alright, I'm sure you need a lot of practice. Okay, then after that, file in your work into your file. Okay? Okay, now let's start our 13.3. By the way, I just double confirm, you all don't have those that wanted to buy the small notes book. You all didn't manage to get it, right? Did you all manage to get the small AMAX one? There is a small copy. You all managed to get it? You never order? Did you order? Wayne and Kenneth? AMAX. There is student revision notes, yes. You never get, huh? So even when you go down bookshop collect, they also don't allow you to take. Oh, okay. Go and collect them, please. So did any of the rest of you, did you manage to get it? You managed to get it? Oh, okay. Because you bought a topical. Okay. Then the rest of you didn't manage to. Okay. I'm trying to work with the bookshop lady, okay, about what we can do in terms of getting that in stock, because I found out that apparently our order was not submitted through, so I'm not sure how to rectify it. I told her to clear out for the set 3s first, because they actually usually order that for the set 3 topical tenure series. So I told her to clear out for the set 3s, then I'll see how it goes. Okay, if she has extra, then that would be great. If she doesn't, then maybe I'll place an order for you all. Okay? So let's look at 13.3. Okay, so in base of change, right, okay, it is actually a bridge for us to go into 13.4. Okay, basically we are looking at how a variable, okay, usually y or x, or depending on the question itself, there may be a context if you're referring to height. Okay, since we're talking about rate, we are talking about how that actually changes with respect to time. Okay, so like for example, speed itself is a rate because speed is the change in distance over time. Okay, so that is what we are going to be looking at. So let's start off with an example. Try 5. So we're looking at a spherical balloon, okay, then after that it is being blown up, alright, such that after t seconds, its radius it has grown to 2 tcm. So if you want to imagine it like a picture, what we're saying is that at the start maybe it's of a certain size, then after t seconds, okay, we will find that the radius itself will be 2t. Okay, so we see that there is this relationship between the radius and time because both are in variable t. Okay, so in this question we want to find out what is the rate of change of balloon. How we can understand this in terms of a notation, okay, is that volume itself, okay, is what we see as V. Okay, so earlier on in the earlier topic of differentiation, I mentioned to you that when we talk about dy over dx, okay, the dy actually represents change in y, dx represents change in x. So when we talk about rate of change of volume, we are actually looking at the change in volume v, and rate itself refers to change in time. Okay, so we want change in volume over change in time. So notation wise, we are looking at trying to figure out what is dv over dt. Okay, but in this question, they did not give us anything that is about volume. Okay, and that is sometimes a challenge, okay, when it comes to this topic itself. Okay, because we need to recognize that we're talking about spherical, and we very well know what is the volume of a sphere. We learned that in maths. Anybody can remember what's the volume of a sphere? 4/3 pi r cube. Okay, very good. So volume, so let V be volume of a sphere, or rather volume of the balloon. So V is actually 4/3 pi r cube. Okay, so you need to be able to draw that link, okay, to create this formula out on your own. Okay, so we need to actually eventually arrive at dv over dt. But at this point, I have the unknowns v and r. So I have the variable v and r. I can at most only differentiate v with respect to r. I can't differentiate v with respect to t, which is what we want. Okay, so what we're going to do is that, because the question says that after t seconds, the radius becomes 2t in size, so our r can be changed to 2t. Okay, then we would simplify this and we get 32 pi over 3t cubed. Okay, any questions up to here? Alright, so after we get the v related to t, we can find out what is our dv over dt. Recognize that 32 pi over 3 is a constant number. We break down the power 3. Power minus 1 becomes 2. So dv over dt will be 32 pi t squared. Okay, so the rate of change of volume is 32 pi t squared. Okay, in this case we got to have our units. Okay, we are talking about volume over time. Volume starts first, so cm cubed, because our radius were given in cm. Over time, it will be in second, because time is given to us in seconds. Okay? Okay, in part 2, we want to find out how fast is the volume increasing when the radius is 8. So we are looking at, we want to know how fast, okay, that means the rate of change in the volume when radius is 8. So when r is equals to 8, we can't directly substitute into this expression that we got from part I, because our expression is in t. So what we can do is to figure out what the t value is using the radius 2t. Okay, so 2t is equals to 8. We find that the radius is equals to 8 when time is equals to 4. Okay, so when time is equals to 4, our volume is increasing at, or rather dv over dt is 512 pi. Answering the question, volume is increasing at 512 pi cm cube per second. Any questions for anyone? Joseph, would you like to go to the toilet? Then could you please give yourself away? Okay, I want to emphasize the importance of writing the last sentence, okay, to answer the question itself. Very often people tend to leave and tell me what is dv over dt, that's it. Okay, when it comes to this topic itself, it is important that you need to interpret your values to the context of the question. So leaving your answer be as a statement, okay, answering the question directly with the units involved, okay, that is important. Okay. Next, part 3. Okay, part 3 we want to find out what is the rate of change of surface area. Okay, so looking at how I have already done part I and part 2, what will you try to do first? What will you do first? Joanne, any thoughts? Sorry? I can't hear you. Okay, formula of surface area, what would that be? Yes, what's that going to be? Yeah. Huh? Any thoughts? 4 pi r square? Okay, yes. So area of a sphere is 4 pi r square. Okay, so please remember that. Anybody has a 10-year series with you for A-Maths? You have? Can you just help me check the formula list? Green and blue one if I'm not wrong. No, that formula list has everything. Yeah. I don't think I get this formula in there. Got? Okay. Oh, Chloe has. Are these formulas inside? I know there are some mensuration formulas inside it. So sphere and sphere is not inside. Then what is inside? Pyramid. Oh, they didn't give any. Oh, okay. Sorry. Must have remembered wrong. Okay, so this one not inside, right? Your formula list. Okay, so please, you got to remember your E-Maths formulas for E-Maths. Okay, so with the area equals to 4 pi r square, now we want to find out the rate of change. That means we are trying to figure out what is dA over dt. What do you think will the next step be? Answer? Okay, find dA over dt. So how am I supposed to do that? Currently we only have A equals to 4 pi r squared. Let R be 2t, okay? So we change our R to 2t. Okay, and we find that our surface area is actually 16 pi t squared. Okay? So with 16 pi t squared, we can now find our dA over dt. And what would that be? Shami? $32 pi t, okay? Because you bring down the 2 times the 16, so 16 pi 2t, 32 pi t. Okay? And as I mentioned, you need to answer the question, so therefore, rate of change of surface area would be 32 pi t cm squared per second. Okay. Okay, last one, part 4. Okay, we want to find out how fast the surface area is changing. That means what is the dA over dt when r is equals to 8. So similar to how we did in part 2 just now. Okay, oops, sorry, this one's supposed to 3. Okay, what we will do is that when r is equals to 8, we figure out what is the t value, which coincidentally is still 4. So when t is equals to 4, find that it is 32 pi times 4, which is 128 pi. Okay, notice that even just now in part 2, I left my answer in exact in terms of pi. Okay, sometimes you may want to leave it in exact, however there's nothing wrong if you go and compute to give me 3SF. But of course, whenever it's possible, it's best to leave it in exact. Okay, especially in A-Maths. Okay. A-Maths somehow you prefer more exact answer in terms of pi or in terms of the square root as compared to E-Maths. Okay? So this is not yet done. We are not yet answering the question. Question is asking how fast is the surface area changing. Okay? Take note, I want you to draw a comparison to the question asked in part 2. Let me just write down part 2's question itself. Part 2 was asking how fast is the volume increasing. When radius is equals to 8. And in part 2 we found that it is increasing our dV over dt equals to 512 pi. Okay, so this 512 pi that we found in part 2 is consistent with the idea of increasing. When we talk about rates of change, we will take the usual convention that positive means increasing, negative means decreasing. be taking this convention, okay, whenever we target any of such question. So when we saw that our dV dt calculation came out to be positive, okay, you need to see that there is that consistency with what the question asked about increasing. So you can say that the volume is increasing at 512 pi cm cube per second. In contrast to part 4, okay, our dA over dt is 128 pi. Question did not say that it is increasing or decreasing. It only said that it is changing. Changes can be positive changes or negative changes. Okay, so to answer this question accurately in drawing the conclusion, we say that, okay, the surface area is increasing, okay, because I can deduce it that this is a positive number. Alright, so we can say that it is increasing at a rate of 128 pi cm squared per second. Okay? Any questions? Okay, so looking at question 7, we have that a petrol costs $2 per liter. Ben drives 24,000 km per year. His annual cost for petrol will be given by 48,000 over x. So this cx function here is to describe his annual cost for petrol, where x is the number of km per liter that his car can travel. Okay, so in part I, we want to find the annual petrol cost given that he drives 3 km per liter, okay, and if we get 8 km per liter. So in this case, we just have to substitute x to be 3 and substitute x to be 8 to find out what is annual cost, since we are given the necessary kilometer per liter. Okay. Okay, but of course we don't leave our answer like this. We answer question clearly. Okay, so annual petrol cost is $16,000 along with the unit. Okay, so in part 2, we want to find the average rate of change. Okay, then tell me how do we do averages? What is average to you? Yes, user. Total divided by what? What is total? Huh? Divide by HD. Oh, okay, so you're talking about mean. You sum things up and then you divide, right? Okay, that's our common idea, very loose idea of our average itself. Okay, so in this case, we're talking about the average rate of change. It is just like when we talk about average speed. Okay, we are talking about total distance over total time. Okay, that's what we talk about average speed itself. But average speed might not actually be the correct representation of, like, let's say, acceleration. Okay, which some of you might be familiar with. So in this case, when we talk about average rate of change in band's annual petrol cost as it changes from X3 to 8, okay, what we will be doing is to take, okay, the cost itself, okay, the difference, and then also the difference in the 3 to 8, the X itself. Okay, so to determine the average rate of cost, sorry, the average rate of change. Okay, if you're talking about, we're always talking about the new one to the old one. Okay, new minus old. So the new one is the 8 one. Okay, then after that the old one is a 3. So when X is equals to 8, our cost is 6,000. And when X equals to 3, the cost is 16,000. So therefore we take 6,000 minus 16,000. Okay? And we would get negative 2,000. Okay? And in this case, the average rate of change is negative $2,000. Okay? And per km, okay, X is number of total we want is over, hang on, km per liter. $48,000. Dollar over km per liter, dollar per km. Average rate of change in per km per liter. Okay, so the average rate of change is negative $2,000 per km per liter. Okay, because on top in the numerator is the cost itself. Okay, the divide sign represents per, right? So then 8 minus 3, 8 and 3 represent the annual petrol cost. X, that represents X, okay, 8 and 3 represent your number of kilometer per liter. So per km per liter. Right? Yes. Why is it 6,000 minus 16,000? Okay, because let's say for example when we talk about percentage change, remember how we do percentage change in EMATS? You all remember that? Okay, you all don't remember? So percentage change, let's say, okay, I give as an example. Okay, let's say, for example, I bought this new bag. Okay, let's say I bought this new bag. Then after that, subsequently, so I need to think on my feet now. Okay, subsequently, okay, so got a bag. Okay, it for example now costs $1,000. Okay, then subsequently got discount, right? So discount. Then after that, the bag now costs maybe $300. Okay, so discount. When we talk about the percentage change, okay, is how it changes, right? So this is now what the price of the bag is going to be. So that's $300. Okay, so when we talk about percentage change, we always take what is it now, okay, minus away the original over, okay, the one that is previously, okay, over the original. That is how we do our percentage change, right? And then we will get our, in this case, negative 700. What would it be? 700, 70%. Negative 70%. Okay? So that is a negative means drop, right? Decrease. So there is a percentage decrease of 70%. Right? So it is currently minus 0.1 over 0. Right? So we use that same idea to talk about average rate of change. So currently it is 8. Okay? So 8, the cost is $6,000 as we found in part B. Right? Previously it was 3. Okay? Then after it cost $16,000. So that's why we take 6,000 minus 16,000 over 8 minus 3. Okay? So then the units, okay, then we will get negative 2,000. So the units, how do I interpret that? Because in the numerator itself, okay, that is in dollars, right? And then we understand the fraction line as per, okay? So it is just our understanding of speed, which has kilometer per hour, because speed is distance over time. Distance is kilometer, time is hour, so km per hour, right? Okay, so in this case, dollars, fraction line means per. The units, okay, for 8 and 3 is originally km per liter, so that's why per km per liter. Understand what I'm saying? Okay? Okay, then now part 3. We want to find the rate of change in Benz and annual petrol cost when x is equals to 5. So talking about the rate of change now, right? So when x is equals to 5, so we see that our Cx is 48,000 over x. So talking about the rate of change, okay, when x is equals to 5, we differentiate this. We find that we get negative 48,000 over x squared. Okay, and when x is equals to 5, we see that we have negative 1920. Okay, so the rate of change in the annual petrol cost when it is 5 kilometer per liter spent, okay, for the car, we will then be having rate of change when x is equals to 5. Okay, the rate of change of petrol cost is decreasing at $1,920 per kilometer per liter. fine. Sorry? AMF and EMF what? Color? File. Why so random? EMF file is orange. Yeah, AMF file is red. Yeah. Okay, any questions regarding that? Alright? Okay, maybe we'll understand it clearer, okay, when we look at connector rates of change. Okay. So 13.3, we'll leave it as that. I will not give you homework for 13.3, okay, because our concern will be more of 13.4 instead. Okay, so I'll give you homework for 13.4 instead of 13.3. Okay. Alright, connector rate of change. Okay, what is it about? It is when we have two different variables. So earlier on when we saw try 5, right? Okay, so sorry, let me flip the correct page. Okay, when we saw try 5, whereby we were talking about a spherical balloon, okay, and we saw that the radius is equals to 2t, okay, and then the volume originally is supposed to be 4/3 pi r cubed. Okay, we could actually put this as a connector rate of change kind. Okay, if I didn't tell you that the radius itself is equals to 2t. Okay, because we had to draw that connection from volume to radius to time. Okay, so that is what we're going to be looking at in terms of connector rates of change. Okay, so looking at try 6. Okay, so in try 5, we're given that y is equals to x minus 9 times square root 2x plus 5. Okay, and in part I, we want to find out what is dy over dx. Could you just spend 2 minutes to differentiate that using product rule? Okay, are we able to get this answer by doing our product rule? Okay. Alright, could you listen up and let me break down part 2 for you to understand? Okay, so what does part 2 want us to find? We want to find the rate of change of y under two situations, x equals to 2 and x equals to 5.5. So earlier on when I showed you how to do rate of change, okay, so rate of change of y will represent dy over dt. So we want to find out what is the value of dy over dt when x equals to 2 as well as when x equals to 5.5. So individually, I want to know what is the dy over dt. Okay? So that's our aim of the question, right? But then the problem here is that in part I, okay, or even earlier at the start of the question, we only know the relationship between y and x. There is no connection with t itself. Okay, so we can do dy over dx, but how do I introduce the t into it for me to figure out dy over dt? So that is where, okay, x is increasing at a constant rate of 2 units per second. It's an important piece of information. Okay, so I want to emphasize on this idea of increasing here. Okay, so when we say that x is increasing, like I mentioned earlier, it means that it is positive. So x is increasing at a constant rate of 2 units per second. That means that our dx over dt is actually equals to a positive 2, okay, units per second. Okay, so positive because increasing. Okay, there are times where we have to be looking at negative, which we will look at it in try 7. Okay, might not be able to do it today, but let's just see what goes on in part 2 first. Okay, so now we have dy over dx and dx over dt. Okay, how do I get my dy over dt? Okay, so we want dy over dt. Alright, notice that it is actually equals to dy over dx times dx over dt. This will be how chain rule works. Okay, coincidentally, okay, the algebraic our algebraic way of doing fractions, okay, seems to be consistent with this notation. I want to emphasize this is a notation. They are not algebra. The coincidence is that dy over dt, okay, equals to dy over dx times dx over dt. It seems as though it's just like cancelling this out and get myself dy over dt. But that is a wrong concept. Okay, I want to say it is a wrong concept to think that way. Okay, because this is not algebra, like I mentioned. Because it's supposed to mean derivative of y, okay, with respect to x, derivative of x with respect to t. Okay, it's just that coincidentally, whoever that designed, I forgot the name of that person, I forgot already. Okay, so whoever that designed this notation, okay, for differentiation, magically it could actually work this way. Okay, but essentially the whole idea is because of chain rule. Okay, so chain rule will tell us that I can differentiate y with respect to x, and since I know differentiation of x to t, okay, chaining means tying up together. I could actually tie it up with the understanding of dy over dt. Okay, so chain rule. Okay, so now how to answer this question? Okay, now that we know dx over dt is positive 2, and we know what is dy over dx, okay, using this chain rule, we see that dy over dt is equals to dy over dx, which is x minus 9, over square root 2x plus 5, plus square root 2x plus 5, times 2. So this is our dy over dx. This is our dx over dt. Okay, we want to look at two rates of change values. First one is when x is equals to 2. Okay, substitute into this expression here. Need not go about simplifying. Okay, just substitute inside it. Paste into calculator and you will get 1 1/3. Okay. Am I right? Please just help me do a check in case I type wrongly as well. Okay, so what we can interpret out of this is that, okay, y is increasing because our value here is positive, okay, at a rate of 1 1/3 units per second. So we do the same thing for x equals to 5.5. We find that upon substitution, dy over dt is 6 1/4. Likewise, it is positive. So y is increasing at a rate of 6 1/4 per second. Okay. Any questions? Alright. So go back and digest this. Okay. We are largely going to be using a lot of this chain rule idea. Okay, I really want you to not think that this is algebra, although it's a very convenient way of thinking. Okay, so we will be using this to answer many of our connected rates of change questions. In connected rates of change, okay, it is actually not scary, so long as you can identify your necessary information and stick to this, creating this equation itself. Okay, there will be no problem in getting your answer at all. Okay. So we look at more questions again the next lesson, right? So that's after Chinese New Year, okay? Yes. What up? We have not chain rule. Chain rule is when